look at this, guys. All right. This one is giving you trouble?
No, 48.
Can everybody do this one? Anybody not be able to multiply this out? Okay, we are row by column. Then in the same row, do the next column. Every time you take a column, take a break. Then in the same row, do the next column. Take a break. So the first row has 3 breaks in it. You're going to be at 3 by 3. 3 rows, 3 columns. Then you're going to add these up. I write mine out so that you can see that nothing's wrong. I like to do this because watch, they all line up. If this side did something wrong and I had a 5 here, it would stand out right away and say, whoops, that 5 doesn't belong there. So you can kind of trace back your rows and your columns this way. And then just even do this piece on your calculator. This gives you one number.
Wait, how is for 47 is 30? How did you get 32?
32. So I'm in the second row. So we did this row, this column. So -2 times 2, 5 times 8, and 1 times -4. Then I came to the next column. -2 times -2, 5 times 1, 1 times 2. Then I came to the third column. So you only want my first column, 32? You only want this piece?
Yes.
Sorry about that. So -4 plus 40 minus 4. Oh, so there's your -8, positive 32. Yeah. Yeah, so this, I like doing it this way because if I make a mistake, I can pretty much see where it is. So we're okay with this? All right, so the next one is a 3 by 3 times a 3 by 2. So you'll result in a 3 by 2. So if you notice, it's the rows that gives you that part. It's the columns that give you those. As soon as you're done with a row and a column, take a break. You're only going to get 2 columns this time. 3 rows, 2 columns. Everybody good with this? Again, 1 to 1. 1, then 12, -6, then 4, 10. Then go to the next column. Take a break, go to the next column. You're going to do this for each row. Okay? Now, see how nice it was when, like Alicia said, that 32 was off and I wasn't paying attention. I was going across the whole row. But you see how we just isolated it to that one area? That's pretty good, right? I mean, even if you didn't show the work and you just were adding it or multiplying it in your head, you know where it points to. You know which row and column is bothering you. This was a big one.
I feel like I got it wrong.
The answers were large. They were large. And you can always put them in your calculator and do a multiply in your calculator. You could put it in matrix A, you could put it in matrix B, and then just come back and do this. This is probably the longest. I wouldn't ask you to do one any longer. Even this is kind of cumbersome.
It's very cumbersome.
It is cumbersome. Okay, so this is 50? Can't do it. That's right. 50 is undefined. And then you had trouble with 59? Okay. Remember we said sometimes instead of using X and Y, they use subscripts. X sub 1, X sub 2. That means I have 2 unknowns. An X sub 1 and an X sub 2. It's the same as your X and Y. But a lot of college books, instead of doing X, Y, and Z, they subscript. X sub 1, X sub 2, X sub 3.
Do we have to put the X and the X1, X2, or can we just leave it like after R, EF, like in the brackets, or do we have to?
Because what I wanted you to do was just to separate this out so that then you could take this answer and you could actually multiply it by A and see that you get B.
Oh, so you do want us to...
I did want you to see that because it's another way. Like, who would have thought that here's your matrix, here's your coefficients, here's your constant, This is your result, your answer, what your solution is. If I take my solution and I multiply it by my coefficients, I in turn get my constants. So it's another way to check that you did it right. It's a little bit more, and to use the word again, cumbersome, because you have to separate all of these matrices, and then you're going to combine it to do your RREF. I get it. So takes a little bit more time playing with the matrix.
I don't really get that.
Well, it is a special little thing that comes as a result of doing your matrix, your solution as a matrix. Yet, if you separate your coefficients and your constant, and then you pull out your solution and keep that in a separate matrix, so out of these three matrices, these three, if you were to multiply your solution times your coefficient, you then get your constant. Something we would never think that, I would have never thought that would have worked, because we use this whole thing to get the solution. So if I now turn around and just multiply my coefficients and I come back with my constant, it makes sense, doesn't it? Because you're actually like plugging in your x values, is essentially what you're doing. So you're plugging back in your x values into this by multiplying them together. It's a weird way to say, does this check? And I also wanted you to see, I'm not going to test you on this, but I just want you to see too that the use of subscripts as well. Like we're so used to using three variables, x, y, and z, that when we get to subscripts, it kind of throws everybody off. But it's the same as your x, y, and z. So now, same thing. You're going to pull out your coefficients, and this guy has to be a 0. You're going to pull out your coefficients. You're going to pull out your constants. Leave this here for now. You're going to rewrite this whole thing, do an RREF. You're going to pull this out by itself and make that a matrix. So when you do A times X, it will equal B. It's just another property that matrices have when you do a solution. And who would think that? Who would think that when you multiply your solution by your coefficients that you get your constants? So it's another way to check your answers. Because essentially when we find them, don't we always plug them in and make sure they check?
Mm-hmm.
So it's kind of the same way of almost plugging them in. A matrix handles it a little bit different. It's a good way to check your answers. If you get that part, that's pretty good. Okay, these guys, if we're multiplying a scalar times anything, remember order of operations. A scalar times anything, it stays the same. Can I add a 2 by 3 with a 2 by 3? Yes, I can. You didn't have to do it, but you just had to tell me that yes, you can. Yes. No, you can't. I did it, but you don't have to do it. A times B, do A times B first. I can multiply anything by a scalar, but my problem is A times B can't be multiplied. So therefore, it doesn't matter what the scalar says. These guys, order of operations says multiply, multiply. So I can multiply those. That's C times A. I can multiply B times C, but my results are not the same dimension. I cannot subtract these. See them? So now it's undefined. And C times a scalar times another scalar times any matrix is fine. That will work. You will end up with the same as A, a 2 by 3. You multiply two scalars, which works, and you multiply by one matrix. That has to work. Okay? That's just to show you, matrices have associative properties, but they don't have commutative properties, and only in an inverse would you have to redo your equations and say, oh, I hate applications. So I gave you the equations.
I still hate them.
I know, but you'll start to like them a little bit better. Now, here's your two equations you have to work with. Here's x plus y equals 23. And then there's another one, y equals 2.25x. Now, if you're going to put these in a matrix, you need to line them up, right? We need to put the x under the x and the y under the y. And it needs to be equal to a constant. So how can I do that? From this equation, how can I do that? Just subtract y, right? So there's the 0. I just want to line this up so that my x and my y, and let's reflect this. Let's just switch this around. So now, isn't this lined up that I can make a matrix out of this? Yeah, we could have substituted it in, but I want you to do it in a matrix. So in your matrix, you need your coefficients and your constants to be lined up. So in your matrix now, you have a 1, 1, 23. You have a 2.25, and then what? A -1 and a 0. So put this in your matrix and do RREF. And see if you come out with these answers. This also lets you, and see if you can flip them to a fraction. Where your calculator doesn't, your matrix lets you go back to a fraction if it's possible. So all I want you to do is take that and put that into your matrix. What's the dimensions for that? 2 times 3. Good. Remember, if you get it wrong, you'll notice it as soon as you do it. You'll see 3 columns instead of 3. You'll see 3 columns instead of, no, you'll see 3 rows instead of 3 columns, whatever. You'll see it backwards. So then you can just like type over it. I got myself confused. Don't forget to quit. So you're going to put this in, you're going to click on matrix A, and you're going to see that we get the same answer. Now here's the beauty of this. If it can go back to a fraction, it will. Before when we did it, we didn't make it a fraction. We used a decimal. So because we solved for x because we used a decimal instead of 2.25 instead of using like 6/4 or whatever we had to use, 8/4. Yes.
For some reason I didn't do that.
Let's take a look at your matrix.
Is this your matrix?
Because that's supposed to be 23, right? You don't wanna? Come on, this works real good. But don't you like applications a lot better now that we can put it on a matrix? Yeah.
It doesn't matter which one is on top or bottom.
No, because it's the way your left statement went. Okay?
I'm still.
Not getting this? Type out your matrix. Let's take a look at it. Let's see your matrix is off. It's not a 2 by 2. It's a 2 by 3. 2 by 3.
Oh, is that a
You're
1?
missing
And a -1?
1, 1, 23.
Oh, I thought. You know what I thought that was?
This was my line coming down.
Yeah.
Sorry, it looks like it, doesn't it? Okay? All you have to do is remember to get these set up the same way. Now, the next one, where we had the stream with the current, you need to set this up to say x, y, constant. So therefore, these are our 2 equations. Once we distribute them, they look like this. So if you want, you could work with those. Just reflect it. If you work with this, just remember your y and your x will just come out backwards. And then you'll just have to switch your answer. Or if you want, you can switch these. -24x plus 24y equals 1, and 13x plus 13y equals 1. The most important thing is the x, the y, and the constant have to be lined up. It has to go into your matrix like that. If you put it in this way, then we'll just have to switch your answer at the end. If we put it in this way, which probably makes a little bit more sense, put this in your matrix, and you should come out with that answer. Just to kind of get you used to putting a matrix in, solving your systems of equations. Again, you have a 2 by 3. All you got to do is click over it. Okay, and we left these in decimals, but if you wanted to, you absolutely could go to a fraction. That's the nice part about this. And if it can't go to a fraction, it won't. It'll stay as a decimal. Just so that you kind of get used to solving assistance with your matrix. Okay, number 3. Try number 3. Number 3 should work for you. Here's one of our investment problems. Here are our 3 problems right here. These were our 3 equations. So let's take the last one and just rewrite the last one because this lines up the x, the y, and the z. Okay. Now, we have to get these into this order. So for the first one, if I subtract 1/2 y, I get x minus 1/2 y equals 0. So I can put the coefficients. 1, since you're using decimals, so 1x, plus I'll change this to a 0.5y. What will my z be? 0. I'm lining this up so this can go into your matrix. I used 0.5 because it was 1/2, so just because you had decimals there. Oh, sorry, I'm sorry. Minus, thank you. Thank you. So I use the 0.5 just because you're using that. Now this last guy, notice you don't have an x, but still move z to the other side. You're going to get y minus z equals negative 1500. So what do I put in for x? 0x plus 1y minus 1z equals negative 1500. Well, no, because I only moved the z to this side. I left the negative 1500. You want your constant there. Oh. I didn't multiply anybody by a -1. I just lined up the x, y, and z. You can't make a matrix unless they're all lined up. So we've got 0.05, 0.07, 0.08. I started with the long one because it already had it in XYZ format. 1520. Then we went 1, negative 0.5, 0, 0, 0, 1, negative 1, negative 1500. Now when you put that in your matrix, you should get that answer. 4,000, 8,000, 9,500. Once you find your equations, you just have to make sure you line them up by your variables, and then your constant is on the right side of that. Because you have to figure there's no other way your matrix would understand it unless it has a certain way that you have to put it in. But look how much work it saves you in the long run. You don't have to do any of this work in here. None of this work. So try it in your calculator and see if you get the right answers.
I'm